voltage must be negative somewhere. But we don't want to see that. Because at 0 degrees Celsius, we would like to see 0 voltage at the output. The only way to achieve 0 volt at the output is to have no current flowing over that feedback resistor. So we must get rid of that current before going into that circuit part here. The only way is to depart that current down to the negative supply. So that means here we got ground, here we got minus 5 volts. So we actually got a voltage drop of 5 volts across our resistor. So the only thing we have to do is to calculate our resistor in that way so that a current of 273 microamps can flow to the minus 5 volt side. Yeah? This is what he is doing. But here we need plus, because you won't find any negative resistances in the lab or in the real world. Okay? So you can use your colleagues can use the pocket calculator and calculate the value. During the exam, you can practice dividing the way you did in primary school, because there's no pocket calculators allowed.
In the exam?
During the exam.
But there is a mobile phone allowed, right?
No.
Also.
And your
No
camera
laptops.
is also not allowed. So no technical tools. But if you got only, you don't have to calculate it up to the last digit. Yeah?
I will leave it like that, it's okay.
Yeah. If you leave it that way and you say, I'm not able to calculate this,
I'll do that. That's a good question.
maybe I bring a calculator. I will take one for everyone, a really basic one.
Yeah, Casio.
Because otherwise, it's everyone. The next one is taking its laptop, and then.
That would be good.
But we have. I would like to see equal chances for everyone, not based on the technical capabilities.
Yeah.
So, but you can just make an assumption. What is this? 5 volts over 200 microamps or 300
It's like-
microamps.
Let's guess.
So 1 volt over 300 microamps is roughly 3K. And 5 times 3K, this you can
15.
It's 15K.
Ah, see.
Somewhere around.
It's 14.5.
18.3K.
But if we take 15K at the exam,
It's okay.
it's okay.
Okay, and you have to calculate RF.
So this is 15K.
At minus 5 volt.
At minus 5 volts. So if you take minus 10 volts, maybe the calculation gets easier. So there's only one resistor missing, RF. So what is the idea for RF? 15K?
Yeah, 50K.
50K.
No, 50 degrees Celsius.
So then is the next step for thinking. What is at 0 degree? All the current that is coming from the sensor is departing to the negative supply. It's dumped. But at 50 degrees Celsius, how much current is flowing now? Maybe we got another color.
50 million micrograms.
It's not 50 times.
Matthias.
Yeah.
But we are only changing from
This?
Yeah.
At 50 degrees Celsius, what is the temperature in Kelvin? This you can do without calculator. You just have to add 50, yeah? It's 3, 12.
Out.
You can also skip the 0.15 if you like, yeah? So we got 223 microamps. Now the sensor is delivering 323 microamps. So what is going on now? 323 microamps are delivered. 233 microamps are still dumped because this is still working here. So we will see here 50 microamps. But there is 50 microamps too much. We are only dumping 273 of the 323. So the 50s are flowing across our feedback resistor.
Mm-hmm.
Yeah? This is too complicated. This is one of the simplest circuits. But we will focus to the simple one. For exam.
But if we don't have the idea in the beginning, then
If you don't have
afterwards
the
it's
idea
easy.
in the beginning, therefore we do it now. So what will we see at 50 degrees Celsius? 5 volts. So that means that across that resistor, we will, or we have to see a 5 volt voltage drop.
Now we can calculate the R.
Now you can calculate it.
Oh my god. Why we don't do the exam like that, like sharing with each other? Sharing
But the
ideas.
problem is everyone would like to see a special grade at the end.
We can share one grade also.
Then you don't trade if you share one grade.
Kelvin.
What?
One grade
Temperature
you
Kelvin.
share.
Temperature Celsius.
No, no.